Let us now study about the ohmic opposition by various circuit components for alternating current. We have discussed about three circuit components. Let's discuss one by one again. First, we have discussed about a resistance connected across an AC EMF, due to which an alternating current flows through it. The situation was this: if this is the resistance R which is connected across an AC source which is E0 sin omega t, we have seen that when the current flows through the circuit, here the peak current is given as I is equals to I0 is equals to E0 by R. Here R is the resistance which is measured in ohms. So straightforward we can say when our resistance R is connected across an AC EMF, the ohmic opposition is equal to the value of resistance. But if we consider the second case in which we have discussed about capacitance across AC EMF, then we have seen that in a case when a capacitor C is connected across an AC EMF, which is again E0 sin omega t, the current which flows through the circuit, it has a peak value. I0 is given as E0 omega c, or the same we can write as E0 by 1 by omega c, which we have seen in the previous cases also. And here we can see this 1 by omega c is a factor which is having a unit of ohms. Then only EMF by this value will be giving us the peak value of the current. So in this situation we can write here the factor, this is denoted by xc, which is written as 1 by omega c, which is also measured in ohms, is the total ohmic opposition by capacitor for alternating current. Here in the circuit, when the current flows, for the path of current, this capacitor is connected in its path, and this capacitor offers 1 by omega c ohms ohmic opposition in the path of this alternating current. Here, this parameter, which we are writing as xc, which is equals to 1 by omega c, is called capacitive reactance of circuit. Here, capacitive reactance is the total ohmic opposition which is provided by the capacitor 1 connected in an AC circuit. We know well that when a capacitor is connected in a DC circuit, in a steady state no current flows through the capacitor and it behaves like infinite resistance or an open circuit. But in case of alternating current, it provides a finite ohmic opposition which is equals to 1 by omega c, and it is called capacitive reactance of the circuit. Let's continue on the next sheet for the last case of inductor across an AC EMF. Let us continue with the case of an inductor connected across an AC EMF. Here also we have seen that when an inductor is connected across AC EMF, the current flowing through the circuit has a peak value given as I0 is equals to E0 by L omega. We have calculated it in the previous sections. And in this situation here we can see that the factor L omega must be having a unit of ohms. So we can write here the factor, this is denoted as XL, which is written as L omega, which is also measured in ohms, is the total ohmic opposition by an inductor which is having an inductance L in AC circuit. So here we can directly state that in case of an inductor, this parameter, the parameter or the factor XL, which is written as L omega, is called inductive reactance of circuit. That means in case of a pure resistance, we simply call it resistance, but whenever an inductor or a capacitor is connected in AC circuit, the ohmic opposition offered by a capacitor or inductor are termed as reactance, or there's given a separate name reactance, which gives us an idea that reactance is the ohmic opposition by either L or C or both. So ohmic opposition due to an inductor or a capacitor or due to both will be termed as reactance. For inductor it is called inductive reactance, which has a value L omega. For a capacitor it is called capacitive reactance and it has a value 1 by C omega.